My name is Varun Joshi. I'm a senior data engineer, and we today are going to talk about the elephant in the room, where how and why these LLM systems, 90% of them actually fail within 6 months of deployment. And I'm talking about any system that is trying to use an LLM at the back end. What I'll give you through this talk is a framework that you can take back and apply to your systems and see what issues your LLM-backed agents are facing and how you can actually fix them. So let's get started. Okay. All right. So what we are going to cover today is first of all, we'll talk about the production reality. By reality, how brutal the difference is between the demo and the actual usage of agents. Then we'll dive into the 7 root causes which leads to failure of production systems. I have listed these root causes based on multiple use cases that I have seen in the industry. Then we'll move into how to do a diagnosis of each case. And finally, I'll show you the playbook to how to fix them with a framework. So that's the big number, where around 80 to 90%, 87% as it says, LLM production deployment experience significant failures. So by failure, I do not mean that they catastrophically die immediately, but it's a slow death that happens within 6 months, where somebody is trying to patch the responses, patch the agents at 2 a.m. at night, but the performance keeps degrading as the model continues to be used. So what happens is it works well in demos, everybody likes it. You have tested it on your maybe 10, 20 test cases, but later in production, something unusual, unseen comes in and the agent or the LLM system actually breaks. Due to this, the user trust erodes. You will obviously have some users who will stay with some bad examples, but then slowly you will have less and less customers. You will have issues such as the API cost spiraling. You forecasted something, but now it's 2x, 3x. And then there are probably the favorite word of the day, hallucinations with all the customers. And again, prompt patching continues. We'll go deeper into all of these in upcoming slides. So these are the 7 root causes of the failure that I have seen. I have labeled them in different colors because the first 2 are in red. Because if that happens, your agent using LLM it's going to get killed immediately. And then the next 3rd, 4th, and 5th, the amber colored ones, they are the ones which slowly will degrade the performance of your agent or LLM. And the last 2 are the ones that we all put it at the back. That's especially the governance. I think it's a common theme in every data project. Governance comes at the end and it bites you back really bad. So we'll go deeper into all of these root causes. First one is the context window abuse. I think we all have done that probably and have been seeing this, that we try to stuff everything into our context window. We try to make it a trash bag rather than giving it documents or details in a sequence. We actually try to think that the agent is going to read 10,000 documents, all those 100,000 messages, and give you the right answers. But that's not true. The model loses its thread and it starts giving you absolutely incorrect answers. The fix is semantic chunking. What does semantic chunking means? It means you give documents based on sequence rather than alphabetical order, or you give the document to agent or LLM the way you would read them one by one. Then the agent will be able to do a retrieval ranking. So what does retrieval ranking mean? It will be able to figure out which are the top 10 or top 20 correct responses, and that will give you much better answers to your questions. And after that, you use a sliding window with summary compression, where as you move your conversation or as the agent learns, it is able to compress the old knowledge that it has received and give you the answers for the next questions. Second is prompt brittleness, which is more or less like a silent killer. You won't see it immediately happening. Prompts are tested by 1 or 2 or 3 types of engineers only, but when it goes to production, you have a customer or a few customers who give the prompt in different types or a different tone, and suddenly the model is or the agent is behaving in a completely different manner that you did not expect. We fail in the third part, which is the edge cases, where we are not really thinking about how the model can fail, but we try to bring out a best demo with it, where we only test on positive and the use cases which are going to give you the right results. In order to fix prompt brittleness, I think we need to treat prompts as well like we do code. So we need to version prompts. We need to test each and every type of prompt with our model or agent and see if the results are similar or not. We need to have two things. So one is a adversarial test suite, which contains your 100, 200 test cases, which are on the negative side as well. You have to try and break your system to know where the vulnerability is. And then there is automated regression on every change. Whenever you are adding more functionality to your agent or to your LLM, you need to have to go through a regression cycle. Any questions till now? All right, continue. Next one is having no evaluation pipeline. I think this is probably the one which will completely kill your system, where you do not know how your system is performing without evaluating it against a golden test set. And how do you make that golden test set? You actually take the real world samples from your customer and you evaluate your whole agent or LLM against it and figure out how good or bad it is doing right now. The second part is how you fix this issue is to have automatic eval runs on every CI/CD. So you need to have a step in your deployment pipeline, which is actually making sure that any change that you make to your agent or LLM is going through that test. And third fix that we have is creating LLM as a judge, where there is another model. I think it was also referred to the previous talk as well, where you have another model that actually gives you a score for your output. Moving on to the next issue or the next root cause, let's look at that number where even if an hallucination rate is like 2% with 10,000 queries, your model or agent is giving wrong responses to 200 of them. How do you fix it? The fix, so there are probably 4 steps that you will have to follow in order to fix this. First one is to make sure that your agent is actually citing the source it is using for all the responses, to make sure it is not making up those answers. Next is to do a consistency check. So you need to give the model questions or tasks which are similar and see if it is able to converge at a similar output or not. If it is giving you different outputs for similar questions, then you can probably gauge that there is some hallucination happening at the back. Next comes the human review. So even though you use your eval, build LLM judge as eval, right? It gives a score. You still need to have a human in the loop which checks the outputs which are very low in score before they go to the customer. And the last one is kind of, I think, important to probably everyone, because the LLMs do not have your domain knowledge. You will have to build that with your agent. And you need to make sure that their answers do not completely go against the foundation of your domain, whichever domain you work in. Now talking about the latency and cost spiral. You may start your model or agent which has maybe 5 or 6 steps initially, where it reads, retrieves, summarizes, and gives you the answer. But in 5 to 6 months, this chain keeps getting longer. You keep adding steps. And for each step, it calls the frontier model, the main complex model. And then you see the cost rising to 3x to 4x. Second is not having any caching or semantic caching for some of the frequently used queries. So the fix actually in this case is pretty simple, which is similar to any other software product as well, where you do some caching. So you need to see that your model is actually using caching for a lot of frequent queries. And second one is probably one of the biggest or the most important part to make sure your cost is not spiraling is using model routing. So you need to make sure that your bigger complex model is only handling the complex queries, and then there is a smaller model that answers simple queries, so that you're not overusing your complex model, which increases the cost. I think last 2 are my favorite because we forget them all the time. So absent observability, you cannot fix anything that you cannot see. We spend a lot of time in building, and we all want to move to production as fast as possible. We all want to show that value. And doing that, we actually forget about tracing. Whenever there is a wrong output from an agent or a model, can you go back? Can you replay the whole scenario? Do you know what was asked, what was responded, and why? If you cannot do that, you won't be able to fix it. That is why observing and adding structured logging along with alerting is very important. Even if you do everything good till having a low cost, having evals, and you do not have observation, you will never know where your model is failing and how did that wrong answer or wrong output task happen. Then we move to governance. Even today, I think when we use maybe Claude, Chatbot, or Gemini, a lot of people are still putting in information about their medical records, their information, which should not be on the public domain. And that PII information is going to go in. And that is true for any agent that you use as well, because there is a lot of information within an organization that should not be read or should be only read after giving certain permissions. So that governance gap actually comes in there. You need to make sure that you have a PII scrubbing middleware, which is making sure that none of the PII is being read and it is being scrubbed off whenever somebody is adding that information or if an agent is trying to read that. You need to have a structured data lineage and data contracts so that when you are actually going back and finding out how this whole trail of input and output happened, you have the reason as well as the lineage defined for you. So this is the diagnostic framework which you can easily use for yourself. This table actually explains how you can actually go from symptoms to a root cause. So I have actually given different colors to them because the second, context abuse, hallucination, and evals, they are red because they are extremely important. If you don't have them, then definitely your system and agent is going to go down pretty quickly. And then you have prompt brittleness and cost spiral, which will take some time, maybe 3, 4, 5 months for you to understand, and then you will see the system falling down. And at the end, the observability and governance gap that we just discussed. So for instance, if the model or agent is giving you multiple answers which you think and seems correct, but it is not giving you citations, it is not really matching with your database, then you know that it is hallucination. Similarly, if your cost is spiraling into 3, 4 times within 2, 3 months, then you know that something is wrong in terms of not having model routing or not having the caching implemented correctly. So this table can be used easily to understand what's happening, what's the problem, and what is the root cause. So the fix playbook has these 9 steps. There are a lot of them, but the good thing is it has to be sequential and you don't have to do them immediately or at the same time. The first one is to stabilize. So by stabilize, what I mean is you should be able to see your system. You should be able to have a framework where you are understanding that this is your system, what your system is actually doing day to day. And you have the structured logging, you have an evaluation set for any change, which makes sure that if anything goes wrong with your system, you are the first one to know rather than the customer. Once you have stabilized your system, you need to solidify it. And how do you solidify it? Is by making sure that you are doing the semantic caching of high frequency queries along with the PII scrubbing. Now, this is the layer where your agent or LLM becomes, or it actually starts gaining more and more trust from the customer. Because now your every response is being checked with a citation. So you are not going to get any random answers or any random output task from your agent. So that is why when you do these 3 things along with the PII scrubbing middleware, you have solidified your agent or LLM to an extent which can be used by a customer, and the trust will keep increasing. And then you have talked about scaling it. You cannot scale without phase 1 and phase 2. And for scaling it, you actually use the LLM as judge as evals now, because once your agent or LLM is being used, you need to make changes to it, you need to make improvements in it. And improvements cannot be made unless you have the eval framework ready, along with the agentic observability, where you are trying to see what the agent is doing at each step. Now, this is what a successful production LLM architecture looks like. And one more point that I wanted to make here, if you see all these issues, nothing is actually the LLM itself. It's the system around that. It's how the context window is being used, how the cost is being spiraled, how there is no observability or governance. So LLM itself is not having these issues. It's the system engineers or the way we are building it. So there is a good thing about it and a bad thing about it. Good thing about it is it's system engineering and it can be fixed. You're not dependent. We have done this for multiple software that have been produced. Yeah, so I wanted to make sure I get that point through, and we move to how the successful production ready LLM architecture looks like. So you start with the user input which has a PII scrubbing, a middleware already implemented. It makes sure that whatever you are entering is safe to be used, be it an agent or be it any model. After that, it goes and checks for the semantic cache, making sure that whatever you have shared, can it be answered with the cache without calling the LLM or not? And then there is a ranking system. And if you see in the first row, LLM is actually at the end, and there are other 4 steps which are happening first, where you are making sure that right input is being fed to the LLM rather than just any trash. Once the LLM produces the output, you have the output validator, which produces a confidence score. And the confidence score can be checked by a human if it's very low, and if it's probably above certain number, then it will directly go to the guardrail and then audit store and response. So guardrails can really vary for you. Obviously, there will be some safety guardrails, but those domain rules, they vary and they keep getting updated. If you work in any domain, new businesses come in or new changes come in, those rules, you have to keep changing. A model cannot use a rule from last year and apply it today. You need to update it. And finally, we have the response. And at the bottom is probably the crux, or I would say the most important part, where every layer has to be observable. It has to be version and auditable. You should be able to see what is happening in this whole process. You should be able to replay it whenever you have to. In step 1, step 2, you should be able to go back and find out, okay, what happened at which stage. And that actually gives you control over the response of your agent or your model. So these are the key takeaways from this particular talk. These demos, there are many demos. You may have created thousands of chatbots using agents or an agent doing 1 or 2 tasks, but when you try to do it in production, it fails. Then we talk about the 7 failure modes that every agent that you create should go through. It should be used as a handbook or as a list of checks that you are doing on your agents or LLM models before deploying them into production. Evaluation pipelines are not optional. They have to be used for every change, and then only the final result should hit the production. Observability and governance, you have to think about them while you are creating that agent or while you are working on that model. It cannot come at the end, because that will cost a lot more than it will cost while thinking about it from the initial part itself. The last point is actually a bit different from this one, because what I want to share here is that right now we have data engineers, we have machine learning engineers, and we have data scientists. But I believe a new type of a role that has to come through to make sure these agents and LLMs work correctly, and that is going to be a data intelligence engineer, where a resource is able to understand how to build these models or agents, how to make sure they are governed, and how to make sure that they are reasoning correctly. So this is something which I want to give you to think about. I think, yeah, that's all from my end.